great job. It cracks me up. Last year, we had people using their phones as hotspots so they could get to their SQL server, and in my networking background, an unauthorized hotspot like that is much worse than allowing people to get to this Amazon server. But we don't agree, obviously, with that. So they would rather you guys use unauthorized hotspots to get to it than allow it through their network. So our SQL server, we'll come back to it and look at it, connect to it here in a minute. But I wanted to talk about some of these other things before we get on that. This assignment here is a discussion board. You don't have to do a discussion, okay? What it is a question for our guest speakers. If you look at this discussion board, it should have the dates in November 4th is when we'll have guest speakers. We have 2 alumni that are working at Jack Henry, and they were so sweet that they offered to come in and talk to you guys and tell you, kind of what the process was that they went through to get their jobs and what they do with their jobs, what a day is like, things that they would recommend to you to help you make that transition smoother. So what I want from this discussion is a question for them. They were awesome, and they were virtual guest speakers for me in the online summer class. And since we didn't have a seated class, we did it through Zoom. And so the easiest way for us was to have questions beforehand. Well, they really liked that format. So they'd like questions from you guys, and they'll go through them before they come in to talk, and then we can do kind of a forum type thing where we can ask them the questions and they can answer. That way they know what your interests are and things like that. The reason I have it as a discussion is because I want you guys to make sure you're not asking the same question over and over. So do look at that as people enter things and be thinking about what you want to ask them. Remember, this is an opportunity to really ask those kinds of questions that have been making you wake up in the middle of the night worrying about things. So don't ask them light, fluffy questions. Ask them important things that really matter to you, because I don't know what those are and they don't either. But we want to make sure to try to answer them. So let's see, Kelly and Matt, they had C#2 together, I think about 3 years ago in the evening class. So that's where they were a few years ago, kind of where you guys are sitting now. So you'll really like them. They're both really nice. Matt has a really cool English accent. So it's neat to see someone that is, so obviously from someplace far away that is here and happy about it. Next thing, links to SQL training. See if you can get to this. Is it not going to? It worked from home. Click on this link up at the top. Since it's not loading, I'll fight with it. So you can always click on that link at the top if Canvas doesn't let you in something. Now, Pearl Trees is just a management tool for websites. That's all it is, nothing fancy. I just have a bunch of different SQL tutorials posted here. So if there's ever anything that you're unclear about, or you want to find out something about SQL, you can come to this link and find all sorts of information. This Microsoft Virtual Academy link is currently the training that they have for our certification that we'll be doing at the end of the semester. So all sorts of different great things for you here. You may not need to refer to them. You might need to refer to them often. So see why that. Yeah. Now the thing is, if you're not in the SQL class, that's okay. We're going to give you the code, and you're going to have everything that you need that is SQL oriented. It's just that it can be kind of overwhelming to people. So just relax, don't worry about it too much, because everybody will help make sure that you know how to work with that piece that's missing. Now the next thing is just a document, and we're going to decide if we need it or not, because we may not, the way things are in this textbook. Speaking of this textbook, if you look at all the videos, there are a lot You're welcome to watch, not watch, whatever you want to do. The first few, this first one is actually from the CIS151 course, which is a business computers class that talks about Access in depth. So this video is an introduction to Microsoft Access as a database management system. The next video shows you how to create a database table using Access and how to utilize that table in a C# application. And then on the other side, you can see how to create the same table using SQL Server and how to convert the application from Access to SQL Server. So those videos are available. Now our textbook approaches things a little bit differently than the previous textbook, so you have an opportunity to learn some different ways of doing things. Okay, so we're going to come back and look at this assignment later. Get started here with looking at chapter 21 in our C# Pro text. So chapter 21 is talking about ADO.NET. Like a lot of things in C#, ADO.NET has had some historical permutations. ADO stands for Active Data Objects. And ADO itself has been around for a really long time. But you guys all know that .NET has really been kind of taking over, and .NET is multi-platform capability kind of implied. So what we're going to see here is database utilities that can be used across multiple platforms. So what is a database? Most of you are very familiar with it. It's organized data, right? So we work with relational databases in our class, but there are other types of databases, and there are types of databases that use different languages. But overall, a database controls the disk space to store the data it organizes. So I can have a pretty huge database. I need to make sure that that disk space is being allocated appropriately. A database actually is just a process, just like a program that's running on a computer system. And the system that's running that process is the database server. Our database server is going to be an Amazon web server. That's why we have the extra security to get to it. But that also means you could go set one up yourself, right? An Amazon web server, because you could set up a freebie one and set it up as a database server if you wanted to.
Is that a thing you will be showing us how to do at any point, or do we need to just look that up?
You could look that up, but I could help you. It's fairly simple. So getting all your data out there is the hard part. You guys know the hard part for getting there. So whenever we have our database, we're going to be using it to allow controlled access to our data and controlled update. So if I have a database, I can actually say, Jim can see all the employee fields. Jose can actually update all the employee fields. So I can secure things down to a really fine level of granularity to make sure that the right people can do the right thing. That's one of the many things I can do with the database. Now, some things that a database has tables that contain data elements to store a specific entity. We've been referring to those as objects or classes throughout our programming development so far. I can take that object or class and make it into a table so that I can keep that data persistently. Now, one instance of an entity, like Joe's student record, is a row in the student table. When I look at a table, each table row has many columns or properties, and a row is equivalent to a record and a column is equivalent to a field. So you can think of a table as just a fancy Excel spreadsheet, right? It's a row and column orientation. So here's a picture of some tables. This is an entity relationship diagram. And this diagram is the database that we're going to create that goes along with our chapter in our book. So our database is going to have 3 tables. So we're going to have a table that keeps track of inventory. In our inventory are going to be cars. So for each thing we have in inventory or car sitting out on our lot to sell, we're going to have a car ID. And then for that car, we're going to know the make, color, and pet name. Do you guys give your cars pet names? I really am not very good at that. But I decided my Prius should have a pet name. So it's Beyonce, because it's, you know, kind of a pain. All right, yeah, super fancy. My sister always does, and so I felt like I had to give my car a name. So this database is going to have that pet name. Now, besides inventory items, we have customers. We don't carry a lot of information about our customers here in our little database, only their ID, their first name, and their last name. And then we have orders. For an order, we could have an order ID, and then we're going to keep track of the customer that was involved in that order and the car inventory that was involved in that order. On our orders table, our primary key is going to be order ID. It's going to be unique for every order. We'll never have a duplicate. We have to always have one unique order ID. So that's going to be our primary key. We have foreign keys also on this order table. We have the customer ID so that we can go back and find the customer that bought this car. And we have the car ID so that we can go back and find the ID of the car that they bought. Notice in our orders table, we don't keep any other information. We don't keep the customer's first name and last name. That would be duplicate. That information belongs with the customer object, not with our order object. So we're going to make sure we keep all of our data in the right place. Okay, so this entity relationship diagram is the one kind of that we'll be using, looking at our database that we're going to create. We're also going to tell the database that these specific requirements exist. That before I can put an order in the order table, the customer ID of that order has to exist in my customer table. And the car ID of my order has to exist in the inventory table. That relationship is called a constraint that says you can't just put orders out here at will. They have to have a customer and a car already associated with them. So we'll look at that a lot. So we're going to use SQL, structured query language, to access our database.
So this is the debate me and Walker were having. Is it pronounced SQL or SQL?
They always say SQL, I think, pretty much. If you look online, see what you can find on dictionary.
You've got an article that's kind of, I don't know if you know the whole PHP thing, how PHP used to stand for, the P used to stand for something, but now it stands for PHP. So PHP stands for PHP Hypertext Protocol, or I think that's what, yeah.
Oh, so it's got itself in its own name.
Yeah, so now PHP doesn't stand for anything, basically, just PHP language. But apparently there's an argument saying SQL doesn't stand for anything anymore. It's just SQL is a language.
I've always said SQL, and then everything for many years said people pronounce it SQL, and so I try to do that. But I've always said SQL.
I mean, if you say either, people are going to know what you're talking. Even if they're snobs about it, they're still going to know what you're talking about.
They usually do.
It doesn't really matter.
But yeah, I don't know who started with the sequel thing, because like it's not there.
Doesn't have an E.
Huh?
It doesn't have an E.
It doesn't have an E or anything. I don't know. I think there for a long time they were trying to get away from acronyms. They were like, people will like this better if it's a word instead of an acronym. We'll make it a word. They tried all sorts of things to friendly us up. And then they figured out, no, just pay them and stick them in a back room. We'll be fine. It's okay. Okay, so with SQL, we have basically 4 statements we're going to use to control our data. So we're going to use the select statement to retrieve data. And in C#, we're going to be usually looking at a list called a data reader that brings back that data to us from our select statement. We're going to be using the insert statement to add new rows. Remember, your ID is automatically set if your database table is created properly. We're going to use the update statement to change data. And we're going to use the delete statement to delete rows. So these 4 statements are the only thing we'll be using for SQL. So it's not like a huge amount of information. When we're using select statements, these are some samples. Our select statement first always says what columns we want to select. The star or asterisk means all columns. Then after our list of columns that we want to select, we have to have the from keyword followed by the table or tables that we want to select from. And then finally, we can add a where clause if we want to specify a specific criteria for what data we want returned from our select clause. So our select clause, remember, is going to return a result set. We expect a whole collection of data. We don't usually just expect one row. That's important for us when we're thinking about how we're going to program this and process this result set from our select statement. Okay, so how it works. We have our database management system down here on the bottom. For us, we're going to be using SQL Server. You guys could use Access. Access is really friendly, makes it very easy to use. We can switch it out with hardly any changes at all. There are many, many others. DB2 on the mainframe. Oracle runs on mainframes, on mid-range, on small end systems. Oracle is a very popular database management system. Informix, Ingress, Sybase. There are so many. You would never want to limit yourself and say, I hear people, it always kills me. I always hear people saying things like, what language do you like best? And it makes me always laugh because I think, I like the language they're going to pay me to write best. That's the one that I want to know. And it's the same with database management systems. You know, if your company wants to use DBMS XYZ, then you're going to learn DBMS XYZ and be happy with it. Now, no matter what database management system you use, it's probably going to use SQL to access the data. Unless you're using one of those new ones that's using no SQL, which is just like SQL with no in front of it. They've tried to come up with a standard language. Now, no matter what database management system we're using, we can use SQL to access our data. On top of that is our programming language. So for us, we're going to be using these ADO.NET classes. These ADO.NET classes allow us to issue SQL statements and get the results back. And of course, C# is at the top because that's where these ADO.NET classes live. So it's kind of like a little pyramid. Everything is dependent on everything else. Our database management system is our base. SQL is right down there with the base, very important. And then we're going to add our stuff on top, layer it. So think about layers like that. So we could actually start the beginning of this semester with working with databases and end this semester with working with databases. We have enough content looking at how to work with database management systems that we could do the whole semester. So don't get overwhelmed, because the idea here is for you to get a taste of it, a feel of it, so that if you're asked to do something like this at work, you'll know how to get started. You might not know how to finish yet, because that's a path you're going to go down when you have to go down that path. In our textbook alone, they talk about 3 different ways to access the database. Connected, which is chapter 21, that's the one we're going to be looking at this week. A disconnected manner, they call that classic ADO.NET. This is in Appendix A. This classic ADO.NET is what all those videos are. So if you go to YouTube and you're watching videos and you're like, these don't seem to be exactly what we're doing in class, you're right, because we're going to use the newer ADO.NET interfaces in class, but the old classic ADO.NET information is available to you on the YouTube videos. This classic is going to be something that you would see a lot at work. Also, we could do entity framework or object relational mapping access of our databases, which is chapter 22. So we're going to look at connected and ORM, but you have the classic ADO.NET stuff available in the videos. So be aware there are definitely some changes, some different ways of doing things, which gives us a lot of power with C# that can be overwhelming to some people. Remember, one of the best things about having this job is that there is a lot of change. It is not the kind of job where you go in and process the same checks every morning. Now, I always used to tell my computer maintenance class that I worked with people who would go in to their job and they would sit down at their desk and they would have a pile of checks or payments, might be online now, maybe not in a pile, but it would be sitting there and they would say, oh, this check pays this bill and this bill and this bill. Click. This check pays this bill, and this bill. Click. And they would do that for 8 hours. They would take breaks in between and go to lunch. Now, to me, that would be really tedious. That would be torture. I would hate that job because I would go in every day and do the same exact thing and it would drive me nuts. So we'd be like, oh, is anything ever going to change? Are we ever going to do anything fun or exciting? No, we're going to process these checks. Other people find that very comforting, that they can go into work, do the same thing every day, know exactly what's going to happen, not have to worry about change. In our field, you need to be a person that is interested in changing dynamic environments because that's what we have. We could sit in one place in CIS for a year without learning anything new, and then all of a sudden we could be thrown into something where the next 6 months we are only learning new things and always feeling a little bit unsure of ourselves. That's okay, that's exciting. Maybe that's more fun than doing the same thing every day. Okay, so lots of change, lots of fun, lots of excitement. We're going to be using system.data as our library, class library that contains all of these classes that we're going to use to connect to the database. Now, no matter what programming language we're using, we have to do the same sequence of things. First, we connect to the database management system. We're going to use a connection string that's going to have our server information, our database information, and how to log on. So, whenever you have a connection string like that, it's kind of not an issue for us. We save our source code to TFS. Our TFS server is private. It's only available to OTC people. If you save your source code to GitHub and you have your code in a public repository, make sure that this connection string information is not in your code. So that's super important. Last semester, bless you, someone in the capstone class did not make sure of that. And I think that we had like, I don't know, several $1,000s worth of Amazon charges overnight because somebody found that connection string information and was able to log on and charge all sorts of things. So be very aware if you save stuff to GitHub, to a public repo, you want to make sure that you don't have this connection string information saved. You can use, one of those GitHub ignore, exclude things, or manually take it out, but do something for your connection string. Now for us on TFS, not an issue because TFS is our private server. We're not saving that anywhere in the public where people can get to it. So once you connect, you're going to run some commands, SQL queries or no queries like updates, inserts, and then you're going to close. You're going to close that connection to dispose of all the resources that were allocated to your program to have that connection open. So no matter what we do, we have to do that sequence of events to process data from our database. So let's try it. First, the utility that we want is SQL Server Management Studio. And the first time you bring it up on one of these computers, you might have to go on your start menu to all programs and go find it because it doesn't show you the right version by default. So make sure you're looking at Microsoft SQL Server Management Studio 18. And find it. Now this is really easy to download at home. And in Canvas, I have the link set up for you to download it. While it's loading, we can go to Canvas and look at our Lesson 9 Setup SQL Server Access link. When SQL Server loads, before it does anything, it asks you, do you want to make a connection to a server? Now, right now, you might already have a server name there in the server name field. If so, you want to delete it because we're going to add a new one. If you don't have one, that's okay. Now, the other things, options on the screen, the server type should already be set to database engine. We want to make sure the authentication is set to SQL Server authentication. Now, our server name is pretty long. If you look at our setup SQL Server access page, it's this bold item, Stu SQL CIS151-101 stuff. Okay, so I'm going to copy that. And then in my SSMS, I'm going to paste it. So my server name field should be full with that whole thing, including the comma 1433, our port number. Okay, now your login should be your username with your initials, and your password is just your number, but no leading zeros. I used Excel to pull our data, so it got rid of leading zeros for me. So if your student ID is 01, you would just do 1. So you should be able to log on. And then for those of you that have the SQL class, the server name will be added to your drop-down list. And we've got the class up here at the beginning of it, so you can make sure you've got your right server when you get connected. Okay, I'm going to put my password in again because I didn't click connect. Now, I like it even for those of you that have already had that SQL Server class, kind of a little bit of review. And that's how this chapter is. This chapter is something where the first time you read through it, it could be pretty deep, pretty high level, not a lot of understanding. And then as you explore things and try things, and you read a little bit more again, then it makes more sense. So it's very deep. Let's look at our databases. Under the database link, you guys should have a database with your username. So go ahead and click on it and make sure it doesn't give you any sort of error or anything, that it lets you actually have access to it. And you should be able to expand that and look to see if you have any tables. And you shouldn't have any because we're going to create some. So we're going to create our database. Are you ready? We have our diagram here. Let me bring it up so that we can all look at it. I haven't printed it out, but it's pretty small, so we should be able to share this and figure it out. We just have a few little fields. We're going to start out by creating this inventory table. So let's see how we can create a table. There's lots of different ways, but using the Management Studio's graphical interface, we can click on tables, and then we can right-click and choose New. Let's go ahead and make it a table. Now, when we say that we want to create a new table, Management Studio responds with this interface allowing us to create our table. And I'm going to make sure here that I do what they want us to. Some things that they mention in your book, if you're looking at the book and following along, some stuff that I want to point out to you. They recommend that you install SQL Server and SQL Management Studio. For us, our SQL server is running on this Amazon web server. So you can access that from home or from here. You don't need to install SQL Server. You can if you want to, but it takes up a lot of resources. It's a very huge hog on your machine. You guys can get that through the Microsoft collection if you want SQL Server. You don't need it. Another thing they mention in our textbook is that this database is going to be named AutoLot. Our database will be named your username. So mine will be Riley R.E. That person's will be that. So whatever your username is what your database name will be. We can't all create an AutoLot database on this server because we would be in trouble.
I can't help but notice there are several, let's say, group 02, 03, etc. as well.
Right. So you'll be using those here in a week or two. Not yet. Hopefully you can access one, but you're not all set up for that quite yet. Yeah, we demolished group 1, if you remember way back. Group 1 is no more.
We actually stopped counting at 1 programming. We start counting 2 now.
Exactly. That 0 stuff, that's for the birds. We just go to 2 and really confuse people. Do our encoding. Okay. So for our database here, the first thing that we need is our unique key field for our car. So we're going to make that car ID. If you look in your textbook, they usually put a lowercase d. Every once in a while, just like me, they'll make the D uppercase along with the I. We're not going to do that. We're going to make it uppercase I, lowercase d throughout our database to try to be consistent. So we will be good people and try to make sure that that's the way it is. So our table first column is going to be car ID, and we want this to be an integer. When you look at the drop-down list of data types, again, you see there are a lot of them. We want the actual INT for this one. Now this is going to be our key field. We have to have a car ID to have a car. We're not going to allow anybody to create an inventory record without a car ID, so no nulls. I'm going to uncheck that. Now on our car ID, we would like for this to be, like I said, our key field. So we can click on car ID and set it as our primary key. Do a drop down here and choose set primary key. Now because our car ID is our primary key, we'd like the database to just go ahead and keep track of the next number and just use it. So we can have that happen if we go down in our properties on the bottom half of the screen and find identity specification. I want to click on the greater than sign by that to expand it. And I want this column to be identity. Right now, is identity is set to no. I want to change it to yes. Now for our car ID, we're going to start it at 1 and add 1 for each car. We have our seed and our increment. We could change that if we wanted to. If we wanted to start, oh yeah, our boss was like, I don't want it to start at car ID 1. That makes us look like we haven't been around for very long. So he wants it to start at 10,025. To look like they've sold a lot of cars already. Could you imagine having car ID 1?
Anyone other than us is going to actually be seeing the
Oh, they might print it on the invoice. You know how managers are. He's not going to listen to that. He's decided. Okay, so next, our next column in our inventory table is going to be the make of the car. For the make of the car, they want us to use nvarchar for 50 and allow nulls. Not going to talk about any of those things other than saying that's what they want. Next, we have our color. And it is also going to be that same data type. And we will allow nulls. We don't care if somebody leaves that out. And lastly, our pet name for our car will also be in bar chart for 50, and we will allow nulls.
There a way in SQL to really accept encrypted data? There's data for the whole thing except encrypted.
No, but you could write like a stored procedure or something to validate that that's what you were putting in.
Just curious.
Yeah.
Because I know SQL has a lot of validation stuff. I just know validation.
I think that it wouldn't care because no matter what you put in there, it would be like, I'm going to put it in exactly as you gave it to
You
me.
can check for strings, like actual strings, not like someone injecting code into your on your website or something like that. But I don't know if you can check it because encrypted would be really weird. to
What
check.
it would do. Let's save that table. I'm going to right click on the tab up here and choose Save Table 1. And this is going to be inventory. Okay. Now, over here in my Object Explorer, if you notice under my tables, I don't see that new table. So I'm going to click the refresh button. And mine does show up now. I see DBO, which stands for Database Owner .inventory. So everyone shall have DBO as a prefix. You are the owner of your database. So you are the one that owns that new table. If you want to expand a little bit more on that table, you can click the plus sign again, and you can see what the columns are and what the keys are, our primary key. They gave it a name behind the scenes. Awesome. So let's add some rows to our table. As a developer, we have to create some test data. So on your inventory table, right click and choose Edit Top 200 Rows to show up. Everybody else see your inventory table? Is it showing up okay?
Sometimes it takes a while to refresh. It's something we've noticed in the SQL class.
It's awful. Yeah, the management studio is like, I do the best I can.
It's weird that it's kind of snappy even for anybody today, though. It might be because there's not as many tables and stuff in each database.
Maybe so. We have smaller everything. Okay, so our car ID, I'm just going to leave null because the database is going to populate that field for us. They have some cars in the book. I'll go ahead and put those in, but you can change your test data. We have a black Volkswagen named Zippy, not Zipply. Now, if you notice, as I typed things, I got little red stop signs warning me about things, and I just kind of kept going because I knew they were going to resolve themselves as I finished adding in all of the data for this row. And sure enough, I got my car ID 10,025 because it used that seed value from that identity column to create that car ID. So there's our first car. Did it work okay? They got cars. All right, let's put some more test data in. And of course, if we were working on a system where there were a lot of business analysts and other people involved, we might not be involved in creation of the test data, or we might be heavily involved as we are here. So this is going to be Rusty. I'm having a hard time with the cars, the Rusty one especially. My dad is going to sell off, as it says in his auction, a lifetime accumulation here in a couple of weeks. So he has Model Ts and Model As and Pacers and all sorts of weird cars if you are a car person. Let's see, we've got a Yugo. That's like his Pacer. It's yellow. And it's called Clunker because Yugos were notoriously awful.
The Model T that someone has a version kit for, like if you go 75 miles an hour. on the wheels, like,
My dad's Model Ts cannot go 75 miles an hour. I don't know. He might tell you they can. I wouldn't want to
like,
say.
when you want to go 75 miles an hour in a Model T,
No, but my dad probably would. I think he has, you know, an old guy death wish where he would like to die in one of his cars, but he doesn't want us to realize that's what's going on. It's like, Dad, it's not that hard to figure out.
What do you think would make it let you like change? I see what you're saying.
What's it doing to you? Let's see. That's the great thing about being in seat. You gotta finish that one. So just, oh, you know, you're like perfect. You know, type in. So ignore that one. Just worry about yeah, I would just. Giving you a hard time. Get used to how you move around. Now, the author obviously likes BMWs. So we have a black one named Bimmer. And it is important that we have all these duplicate makes in here for our queries. So make sure if you don't use the BMWs, you have duplicates of some sort.
why is it like flash the last few injured person? Like when you get injured,
Uh-huh.
why is it flash?
I assume that's just the process of it making it into an actual row.
Yeah, it checks all of your rules and all that great fun stuff. Okay, got data? Now we're going to create one other thing here. We're going to use a stored procedure. So we're actually going to create that in our database. So we're going to do some coding. They say right-click the stored procedure node. Where is stored procedures? Oh, I see. Under programmability. I didn't know what category they had stuck that. So under our programmability, that word I can't say, we have all of the different programming type things we could save in the database. There's always discussion back and forth as to whether rules should be coded in the database or coded in the application code. And of course, the best applications will have safeguards in both places to make sure that data is valid. But we're going to create a stored procedure. Now, a stored procedure is something that is program code. Let's just create it. Right-click on stored procedure, and they say select stored procedure. Now, over on the side, instead of having your table data rows, you should see this stored procedure template, which is kind of huge. We're just going to delete it. So press Control A and just delete everything. Now for a stored procedure, we're just going to type in exactly what they have in our textbook. They want this stored procedure to be named get pet name. Now our stored procedure is going to have a couple of variables. variables in stored procedures start with @ signs. So I'm going to have a variable car ID that's an integer. See how I made that D uppercase? I'm going to make it lowercase. Car ID. And then I want one other variable, pet name. Yeah. So I'm declaring an integer car ID, and I'm declaring a string that's 10 positions that's going to be used as output named pet name. Now the code that is going to be saved in this stored procedure is just the select statement. We're going to be using the select statement to find the pet name. I'm going to make this all uppercase. In our SQL book that we use, they always make all of the SQL keywords in uppercase. So I'm going to try to follow that same guideline. Our textbook here does not do that. So you can see it's not really a rule, it's just kind of a preference. So what we've done here is created this stored procedure, which is basically this one select statement. The select statement is saying, select the pet name from the inventory table that we just created, where our car ID equals some car ID. So we're going to use this stored procedure in our code to pass in a car ID to get this information back from the database. We don't have to create it as a stored procedure. This is just one way. It works well.
Question.
Mm-hmm.
Why did we do character 10 when we declared pet name? Did we not declare it as a character 50 when we were creating the table?
Yeah, they must have decided that it's only going to be 10.
But it wouldn't actually impact our code to make it take it. Make it
Right.
50, so it's the same.
It wouldn't. Do you want to? I would feel better about it. Let's make it 50, since we said it could be up to that big. Now, when we create a stored procedure, it's a little bit different. We're actually creating an item in the database. So if we had to change it, we would drop it and re-add it, recreate it. So just to make our lives easier. Now, I'm sitting here in this query window, and I have this query, which is really the creation of a stored procedure. So I'm going to execute it. Now, once you execute it, if you look in the Object Explorer, you should see that stored procedure.
So it's kind of just like regular, but like the actual code is written, doesn't matter. It matters that we executed it once.
We can just execute it whenever we want to. So it's kind of like a saved function that has SQL code. Now, in our get pet name stored procedure, if I right click and choose properties, I'm not going to see the code. It's the weirdest thing about stored procedures. Once you've created it, it's really hard to get back to the code. So a lot of people will save this query code. So let's do that. On your tab, right click and choose save. I want to save that, I think, to my CIS151 folder. I think I'll create a new folder, maybe. And I'm going to call mine DB Setup 101 for our class. And then I'm going to actually make this file name be get pet name. And I'll put the word stored procedure on it so I know what that is. Now it's going to be saved as a .sql file. And by default, if I double click on a .sql file, it's going to open that file in this SQL Server Management Studio. But these stored procedures are kind of a weird DBA nightmare because they're not really, the source code isn't really available once they're saved. So we can see what parameters we have and that it returns an integer. The only way I could see this code is if I chose script stored procedure as, and I'm going to choose create to new query editor window. And then I can see the create procedure statements just like I put them in. Okay. So the stored procedure is kind of super advanced. We don't get to that till the end of the SQL class. So we won't be doing a lot of this, but we did want to have this one saved so that we could use it. So everybody got it saved okay? I'm going to make sure we have that already for us. Okay, let's create our customer table. Before we do so, let's clean a little bit up. We have a lot of tabs open here. My get pet name stored procedure is one. I'm going to close it. My data for my inventory table, I can close it. And then my creation of the inventory table, I can close that tab. I didn't need to save any of those. Okay, so we have our great inventory table. We need now to have our customers and orders table. In the book, they want to show you how to do things every possible way. So let's try it. Click on New Query to open a new query window. In your database, let's go ahead and make sure we're using your database. We're going to create another table. Last time, we right-clicked on tables and said, add new table, and we used the GUI facility to create our table. This time, we're going to create our table using syntax. So we're going to say create table instead of letting that, oops, not able table. Instead of letting the GUI create it for us. Now our table name is going to be customers. And after we specify our table name within parentheses, we're going to specify all of the columns. So just a little bit different of a way to do it than using the graphical interface that we were using before. Now the first column we want, we're going to surround the column name with square brackets. And that tells the database management system to not try to figure out if this is a keyword or anything, to ignore any special characters that we might have in this field. Okay, our first field that we're going to create in our customers is going to be our customer ID. It's going to be an integer. And again, we want it to be an identity column. Because it's an identity column, we need to pass in its initial value and its seed value. And then say, this thing cannot be null. Now remember, our customer table didn't have a lot of columns. It has first name, which we're going to make and varchar 50. And we're going to allow nulls. It has last name. And allows nulls. And we've got to say what our primary key is. So we did all of these same things with that graphical user interface for our first table. This time, we're going to do it with code. Clustered means that it's the data is saved internally on disk, clustered by that key. So the customer number 2 will be close to customer number 1.
That'd just be cool to have like multiple primary. I mean, you could sometimes do that with more keys, but multiple primary keys.
Well, you could have like a group, you know,
Yeah.
data item.
Why would you want multiple primary keys? That seems absolutely.
You sort of can, because you just create indexes on your other ones. And then you've got a path into it. It's the index. Okay, so this is our create table statement. And the reason that we want you to be exposed to all these different things is you could actually have an application, a C# application, that creates the tables, right? So think about it. You're going to have an application that you're going to send out to everybody in all of your different locations. You have 75 different locations across the country. You're going to send this application out to everybody. You're going to be using a table that's new, that's not already in existence, but the database is. You could actually have your application run this code to create that table the first time it runs. You know, if this table exists, don't worry about it. Otherwise, create this table. So oftentimes people will do that. They'll have create statements in their code to create the tables that they need. Remember, there's a security issue there, though. You know, I can't have users do that if they don't have access to create tables in the database. So I'd have to be aware that they need to be able to do that. Let's run it and create that table. Right now, we just have the syntax sitting here. We need to execute it. You should see a successful completion message. And then again, you want to go to tables and refresh. And now I have my customers and my inventory table.
It would just give you an error.
Yes, if you try to execute it again. Yeah, you would just get an error. So no big deal. It's already in use. Okay, so let's add some test data to our customers table. Right click and choose edit top 200 rows. And for our customer, again, our customer ID is an identity, so we don't need to worry about adding that. We've got Dave Brenner and Matt Walton and Steve Hagen and Pat Walton. Our dealership is in Northwest Arkansas.
Have you ever been to the original Walmart? I'm guessing that's what you're talking about.
Right.
Yeah. Have you ever been to that?
There's like a museum, Walmart
Yeah,
museum.
There used to be like an ice cream shop. It's actually kind of cool.
Is it neat? That's what I've heard.
Yeah, it's
Friendship
it has, like,
God.
it's a little museum there, but like the town's pretty cool. But like nothing like crazy interesting. Like here, it's not like, oh, let's go have a whole vacation.
Crystal Bridges is pretty nice. I could probably spend 2 or 3 days at Crystal Bridges Museum.
But it's crazy. I think it all started right there. But now it's like they have Walmart in third world countries.
Okay, you've got customers, you've got inventory, you're good. Let's create our connecting table, that link table, our orders, because that links our customers to our inventory. So that's how we would refer to it. We can actually just click back on this tab and add another create to this query that we're building here. And this time we're going to create our table orders. people have different opinions about using the GUI and using the create syntax and all that. I know some people say, oh, a real DBA is going to do all of this create. They're going to type everything by hand. As a real DBA, I can tell you that sometimes it's hard for students to keep up with me because I do have a lot of typing experience from being a DBA and from typing crap like this over and over. I remember my boss saying, now sometimes I think you're just going to set that keyboard on fire. It's giving me crap to do. Yes.
So I closed the window.
Uh-huh.
So what should I do? I mean,
Just create a new one. Just open a new one. That's fine. It won't cause any trouble. You can do it. Just create it. So you got to type a lot, but you don't have to always do this. So people have said, when you were a DBA, what did you do? Well, I did a lot of typing, but I would use this graphical user interface. If I were creating a table for the first time and I was trying to decide what the best way to set it up would be, why would I not use the graphical user interface? That's going to save me time in getting it set up for the first time or changing it. But then I might be able to do typing syntax if I want to update it. So just remember, you have all these options available. That doesn't mean that one is better than the other. One is going to be better based on different situations. Now I'm going to add our order ID. It's an integer. It's not null. It's going to be our identity. Now in this identity field, we're just going to leave it without any parameters. It's going to just take the default 1 and 1, which is just the same as what the parameters were in our earlier table. Now I'm going to tell this table that it has a customer ID that's an integer and not null. And then it has a car ID. In our orders table, our order ID is our only identity column. The customer ID is an identity column in our customer table, not in this one, because it can only be an identity column in the one table that it is used for. And our car ID is an identity column in our inventory table, not this table, right? So for this table, the only column that's identity is our order ID. That's all. Notice we're not adding a primary key. Ooh, bad. I'm going to select this before I click execute because I only want to run this.
Why aren't we adding the primary key? Yeah.
I think to show you that you don't have to.
Okay.
If you would run the whole page, would it still create order tables or just fail on the
Yeah, I would just fail on that first
I
one.
was curious if it comes first and then fail the whole thing.
Now I'm going to click on my tables and refresh again.
I think we found the tipping point.
Did we? 3 tables makes it slower.
Well, 2 tables on each student.
Now again, I have this syntax here to create this table, but I could go to the SQL Management Studio and right click on my table and I could say script table as, create to a new window, and it will generate that create table syntax for me. Okay, so it will just do it. So I can always, any entity in the database, I can right click and say script as, and it will show me what the syntax is to create that thing. Okay, just in case you need it. So we've got our create tables done. Let's add some test data for our orders. So I'm going to right click, bless you, and edit top 200 rows. Now for our car ID, or our order ID, I'm sorry, is identity, so I can tab past it. Now our customer ID, let's say customer number 1 bought car ID 5, which means I'm going to have to do some thinking. 10,030. Oh, that worked. That's what I get for messing with their test data. Customer ID 2 bought 10,025. the first car. Customer ID 3, bought 10,029, the fourth car. Now, if I decided that that identity column was just driving me crazy and I wanted it to start at 1 for my test data to match, I would actually have to drop that table, delete it from the database, and add it again to change that identity column. Because otherwise, it's already set. It's not going to change it. So I'm okay with it. But if we get to a point where it's driving us crazy, we can fix it. 32 would be customer number 4's stuff. Okay, so now when I look at this order table, it's not meaning much to me. Notice how when you look at the order table, you don't know anything going on here. You have to use this customer ID to go back to the customer table to find out what customer it was. You have to use the car ID column to go back to the car orders table to find out what inventory it was. So these linking tables like this that are only keys can be hard to look at. We have to have relationships in the database to know how we can look at them. So we're going to try a database diagram. This hasn't been working well in our SQL class. So let's see what happens. We're supposed to use it. They say, click on database diagrams. Let's watch SQL Server Manager crash. Double click the database diagrams node. Oh, that's what it's supposed to do. It's supposed to say you do not have one of the support objects. Yes, we would like to create them.
What if you clicked no?
Double click it again. Hopefully it'll ask you again. Is it doing it?
No, it didn't crash, but it's not doing anything. It's just
Okay, so now we're going to right click and create one. That's where it crashes. New database diagram. Oh. Huh? Now we want to select all of these and click add. So I just did shift select, click add. And here it goes. No, don't crash, don't crash. It didn't crash? Is it gonna work?
Not this
Work, you
probably
piece.
because we all hit it up.
Yeah, we broke it.
We probably should have like staggered them. Like,
That shouldn't matter. Silly database. Okay, I think it's done, so I'm going to click close. I'm just like waiting for it to go away. Oh, look, it did it.
wait for it to crash.
Yeah, waiting for all of it to go away.
That looks nice.
It looks nice, doesn't it? Okay, has everybody got a database diagram? Did it let you create one? Because we're going to do stuff with it. Let's make sure everybody's got one. Okay, so we're going to create our relationships in our database diagram, our entity relationship diagram that we looked at earlier. Come on, you silly thing. We see that we have these relationships where we can't have a order car ID unless we have that car ID already in our inventory table. And we can't have a customer ID on our order unless we already have that customer. So let's create those relationships that keep those rules. Let me see how they want us to do it because I didn't think it would work. Click the car ID column in the inventory table. I know. And drag it to the orders table. Click and drag. Come on, you silly. Oh, you got to get the little square.
You got to click the actual box, not the. All right.
Yeah, the actual little box beside it with the key. Did you get it? Yeah, let me try. Let me show you again. Okay, so I've got my inventory car ID. I'm going to drag it and drop it on the orders car ID. Now the relationship that pops up should say F key for foreign key underscore orders underscore inventory. Does that look right? Our primary key table should be our inventory car ID. Our foreign key table should be our orders car ID. If that looks good, click OK. Now, on this relationship, we can use this screen to specify specific rules. And we want to expand this insert and update specification. Now, our delete rule has to do with if somebody deletes a car from our inventory, what do we want to have happen? Well, we would like to cascade that, meaning we would like to also delete the orders associated with it. Now, for an update, same thing. If somebody updates an inventory item that affects this order or an order, we would like to cascade that update.
So we need to do here.
I think so. So let's say okay. And then we need to do the same thing with our customer. So grab your customer ID and drag it onto the customer ID of the order. You should see foreign key orders customer. Our primary key table should be our customers. Our foreign key table should be our orders. Let's fix our insert and update specifications to cascade. And that should be all we need to do. If you notice up here in the general section, it says check existing data on creation. That's already set to yes. So that's going to make sure that that owning table row exists. I'm going to click OK. Do what?
The key, the relations don't line up. Like, it's not, it goes, yeah, it just doesn't do it by default. It makes me always confused. Like, oh, first name goes to customer ID, car ID goes to order ID. That's how I read it. Or
Yeah, me too. I don't know why.
you could move them, but it's just like, I think they would like.
Well, and I think it'll move them back on you if it decides to.
Are you talking about the little connected one?
Uh-huh.
Oh, that's bothering me.
Yeah.
You can move them, but it's just like, why wouldn't it? Because those are like, because you can have like first name, you can, because you have like 20 different foreign keys or something. I don't know why you would, but
Right.
it's really confusing. Like all of them coming off, like, okay, where's this guy going?
I like having it that way. I really do. Making sure that we.
Cases where you might have that many foreign keys.
We have got so much information here. Okay, so we've got our database all done. Let's create a factory model. Let's see, I'm looking at time here. About 30 minutes. I know a lot of you were worried about that unit exam. We're at a really good stopping point. So I think this would be a great place for us to stop for today to use the rest for lab time for you guys to finish up on that unit exam. Now, we've got a lot to do here because we haven't started coding. So next time on Monday, be ready. We're going to be, doing a lot of coding to experiment with this database, get everything working. So.
Where should we save this?
Oh, yes, let's save this. They say their recommendation is to save it as AutoLot diagram because this is the AutoLot database. So I'm going to actually put that on mine because I'm going to forget that they named it AutoLot. AutoLot diagram. Now, does it crash when you save it? I think it's trying to create our table. Unable to create relationship orders. Did you get a relationship error on inventory?
Where'd you say that?
We are saving it as AutoLot.
How does he save it?
We right-clicked on the tab up here to save as, and when you actually save the diagram is when it's trying to update everything to create those relationships. So we're getting an error. The alter table statement conflicted with the foreign key constraint. You're saved. Well, I'm going to click OK, and then I'm going to check. So now if you look at your customers, you should just see your primary key. But if you look at your orders under keys, I got to refresh.
I didn't say. Yeah, there's nothing under keys to order.
Yeah, it didn't. Did it save yours?
I did the orders.
You got them all?
We saved it and then we keep it. Oh, mine saved. It's because I don't have a key in order. We have keys in inventory.
It's because what?
We have keys in customers and inventory. There should be no keys in orders. Right?
Right, but there should be constraints. I'm going to try saving it again. Well, why did yours work, Michael? I'm going to save the text file and see if I can run it. Okay, I just deleted my relationship between the inventory and the orders, and I'm going to create it again. So I deleted my relationship and saved. Now I'm going to create it again. Let's see if I can save now.
I don't understand this one. Yeah, I should.
For example, yeah, like if you was to turn right here, and this would be true, right, this would fire true, and it was the first one, turn right here, it would just break it all, right? We're not breaking it, shoot out. Yeah.
Because I haven't worked, like, it works here. I'm not sure.
I don't think you need it because
But
You have to delete it just to save it and figure out what's going on. Here's the answer too.
I deleted this, but then when I saved it, something popped up to save this. I don't know. I think you save it right here. But this I have
Just gonna delete that relationship. You guys see, save that and I'll figure out what's going on.
I already
Did yours work with it?
right. I just
no, it's gonna say
Just put it back in. Yeah, the one that it doesn't like.
That's the problem I kept reading.
Experiment with the other class this afternoon.
You just have to turn outside the photo because
You
should break it. So no, this is thing that's so what you do.
Yeah.
We'll figure out.
So it's kind of like default.
The default state, this is all
Yeah.
false. Should be noticeable. So if this goes to the whole loop, you have the spots.
Yeah.
So it's just. Leave that shit. Let's see.
So first off, it should be
You're like, are these slots to like check out?
oh, going in order. Yeah, that should go to 25. For it. It says no spots available.
Figure out why it was hard to create that.
Is that the last thing we need to do for this with them? Okay, cool.
Oh, no, this needs to be if is but the max, right? This needs to be if. This one, right?
If it lets you save it, just delete whatever you need to sort of let you save it.
Save it?
I like to-
Yeah, no, it's fine. I'm just.
I don't know if it's safe or not.
Yeah.
Like my deed.
Right, she was just saying, let's delete these and then save it. And then she's gonna fix it.
Yeah. 25. Yeah. So, yeah.
Unless we exit the one main
Yeah, because that's just kind of the tricking it essentially.
Of course, we're going to do that. So.
I mean, this is not a bad way.
Yeah.
This is
It's
just
just a little more efficient.
Yeah, I mean, a lot of those lines. Yeah, kind of use the what? One. So you make up one line.
Yeah.
All right. Well, no, because the if statement still counts. I like that. One.
I don't know why.
You don't know this.
I think it was the last meeting.
I started writing on the last line. But it's a little bit easier than this. You might ask that.
Yeah.
You're just like, okay, so we're just doing this radio. Oh, it's down. You know what I'm saying?
Yeah.
You have to go, oh, what's the second word? I guess I think that's you. You like an hour. So that's the kind of game. It's text available. It's just working. So if there's a big business, maybe not really.
Okay, so let's write about
Oh, that's what you think.
Yeah, because this one increases every time. So let's say, like if they check out, I just move on to that. I don't remember.
You check out to get
Yeah, so it's not a 3, but 25 will be.
Yeah, I'm saying that spot.
So if these,
like it,
so like your right, so if you check, you see, you see like I'm in the middle.
I get where you were going with it.
Yeah.
You should just have in this like spots.
Yeah.
I use an array.
Remember running
I use an array.
Yeah,
They tend to want to check down numbers, so it will say the biggest. So like equals. Yeah, it's the same biggest number. See, right?
Where you're right now. Is that where you're right?
Yeah.
Okay, so and then what are you doing? So that you're creating.
Yeah.
Yeah,
So
not really. I have
to
to go on this. I only use that for. I just have so much stuff. So we need to track on what I'm taking and check now.
I transfer. Let's just get in next to the array.
Why do you need that?
Okay, I guess yeah, the first one would be triggered at 0.
Yeah, yeah, but it's.
Array's like still in some way.
What do you check on the middle?
I know where that's how much. It's granted.
Yeah.
I'm just adding
One.
I think let's add that ticket to the spots. And if you go to my phone, so tab over the tickets.
Okay, here.
Oh, yeah, so as you create tickets, it's loaded into this, and now we keep track of it. And that's what's Chrome.
So you're just doing
So I'm just adding one.
If my.
And then it gets updated with Chrome to update.
I get one I check now.
It gets put in with a default.
So basically you do that.
Yeah.
But with that, if you don't work,
Okay.
that's from mine. Yeah.
It's one of these. It just updates that. Next.
If we do one again, it'll say.
I'll show you.
Because it's that next one.
Then you check another one.
This is weird because I kept on uploading the last time twice.
I was stretching that.
Yes, like I'm 25 and 25.